At the equator, one line cuts across the sky. Near 40 degrees, it opens into an arch. Above the Arctic Circle, it vanishes. What if Earth had rings like Saturn? We are stipulating the hard part. A captured rocky asteroid was torn into a thin equatorial swarm. It is dust, gravel, and tumbling rock, not a solid sheet or bright Saturnian ice. From the ground, it looks permanent. Keep that thought. Its mass stays modest. The moon remains, ocean tides keep rolling, and Earth's day barely notices. The first changes come from geometry and light, not the gravity of a second moon. On the equator, you stand inside the ring plane. Billions of particles align almost edge-on, so a structure thousands of kilometers wide collapses into one narrow stripe overhead. Move into the middle latitudes and the angle opens. Around 40 to 50 degrees, that stripe becomes a broad, dusty arch. The same rubble now occupies a huge piece of sky. Near the poles, Earth's own curve rises like a wall between you and the ring. With our outer edge at 2.5 Earth radii, it swallows the last sliver around 66 degrees latitude. Farther north, the sky is empty. Latitude changes the basic shape of the sky. One child grows up under a line, another grows up under a ceiling-sized curve. Both live on the same planet. Both call their version normal. Keep two geometries separate. Your latitude controls the ring's apparent shape. The sun's position above or below the ring plane controls its lighting and the shadow it throws across Earth. Near solstice, angled sunlight lets the particles dim a band in the winter hemisphere. It would be a migrating belt of reduced light, not a razor border cutting one farm cleanly in half. At equinox, the sun lies in the ring plane, so a thin ring casts almost no broad planetary shadow. But the arch above you does not collapse. Your latitude did not change. Its illumination did. A 2002 climate study pushed this mechanism to an extreme. A completely opaque ring roughly 1.5 to 2 Earth radii from the planet's center. At solstice, its shadow spanned about 13 degrees of latitude. That result belongs to that ring. Make the ring thinner, darker, wider, or full of gaps, and the shadow moves and weakens. Inside that modeled shadow, tropical and subtropical temperatures fell sharply, rainfall shifted. Even after 16 simulated years, the atmosphere was still adjusting. The model planet had not settled yet. The useful result is the mechanism. Remove tropical sunlight, and atmosphere, ocean, ice, and clouds redistribute the loss. Some regions dry. In that run, some monsoon regions became wetter. Our ring would make a patchwork. At the dimming belt's edge, a farmer might delay planting as cool soil arrives earlier, while a distant forest changes less. Surface instruments could watch that boundary migrate as heat and weather spread its effects. The same particles could brighten parts of the night side. A study of a different artificial ring found nights many times brighter than a full moon. Darker rock, open gaps, and changing seasons would alter the glow. Picture a moth navigating by a ring-lit horizon while a high-altitude satellite maps the glow below. Which species adapt would need measurement. Reaching that satellite's orbit raises the next question. How do you cross the ring? Space would not become uniformly unusable. Our ring starts around 1900 kilometers up, leaving most low orbits inside its central hole. Higher orbits can still exist beyond the outer edge. Moving between those safe regions is harder. A transfer crossing the annulus needs a real gap, the central hole, or a route around the outer edge. Each option costs timing, fuel, shielding, or payload. NASA says today's orbital debris impacts average about 10 kilometers per second. That is not our ring's predicted collision speed. It simply shows what tiny particles can do when two orbital paths cross. Why not immediately become a moon? Much of the rubble sits inside Earth's Roche zone, where tides hinder large-scale reaccretion. They do not forbid every clump, and the boundary depends on density and structure. Collisions also trade angular momentum. Unconfined rings tend to spread, some material inward and some outward. But there is no honest countdown. Particle size, mass, moons, gaps, and shepherding control the lifetime. Across 1 year, the shadow acts like a clock hand. Widest near solstice, nearly absent at equinox. Different places see different skies at different local times. The shared signal is geometry, not one synchronized spectacle. Earth would carry two clocks. One sweeps a shadow through the seasons. The other is slower, written in a ring gradually changing shape. The planet's largest sundial would also be temporary.